Hello, welcome to our channel and in this lecture we are going to discuss about the quantum numbers. So this is a lecture 5. Okay, now let us start about our discussion the quantum numbers. So actually what the quantum numbers is, what they are going to say. So these quantum numbers are going to say or give you the information about the electrons. So if in the previous lessons we have discussed about the orbitals, okay, shells, subshells and electrons, okay. So around the nucleus there are shells, okay. In the shells you can see the subshells, and in the subshells you can see the orbitals. The orbitals contains electrons. Okay, these principal quantum numbers, these quantum numbers are going to describe about these electrons. They are going to provide the information about these electrons, where are they present, in which shell and which subshell, and so on. So these information completely given by the quantum numbers. Simply you can say these quantum numbers will give the address of the electrons, where the electrons are present in the atom. Okay, actually there are three quantum numbers. Okay, so that is nothing but principal quantum number, angular momentum quantum number, magnetic quantum number, and fourth one is the spin quantum number. But the first three quantum numbers are going to give the information about the probability of finding of electrons, okay, in the space around the nucleus. So just they will give the information where the electron can be found and about that information. Okay, so first we will discuss about the principal quantum number. The first quantum number, it is designated with the small n. It is nothing but the principal quantum number. This principal quantum number is going to describe about the size, energy of the main shell. You can call the main shell as the shell or energy level. Okay, so the principal quantum number has the positive integers. So what are the positive integers? That is nothing but +1, +2, +3 and so on. These are nothing but the positive integers. So here the next thing is, main important thing is, as the n increases the shell becomes larger and electrons in those shell will be farther away from the nucleus. Okay, here we can see the n is equal to 1. In the n is equal to 1, that is nothing but the first shell. The shell contains subshells, the subshells contains electrons, or you can call it as the electrons of the first shell. Okay, so in the electrons of the first shell, so here you can see the shell, the electrons are here and here in this. So the electrons are much closer to the nucleus. Why? Because the distance is very less. And if you see the second shell, so from here to here, the electrons present here are little bit farther away from the first shell. So now move to the third shell. In the third shell, the electrons are little bit farther away when compared to the second shell. And now move to the fourth shell. The electrons are even more farther when compared to the third shell. It means what you can understand from here, or what you can understand from this, you can understand that as the shell value increases, or as the principal quantum number increases, the electrons in the shells also increases, or the distance from the nucleus to the electrons increases as the principal quantum number increases. Okay, so this is about it. And now next thing is, these shells also represented with K, L, M and so on. So or you can represent the principal quantum number with numbers, that is nothing but n is equal to 1, n is equal to 3, n is equal to 4 and so on. So 1, 2, 3 and 4 and so on. By this way you can also represent it. Okay, so next is angular momentum quantum number. This is second quantum number. It has the L. It is nothing but L value has the value from 0 to n minus 1. It means it contains 0 value or it contains n minus 1. So what is meant by n minus 1 rule or n minus 1 formula? It is nothing but, n is nothing but principal quantum number that we have discussed just now. So let us consider the principal quantum number is 2. In that case, so n is equal to 2 and minus 1. 2 minus 1 is equal to 1 only. So here come and see here, in the principal quantum number the value is the second principal quantum number. In this you can see the value is 1. It means you can apply this formula by this way, the values are same. Okay, so now let us see another example. The third quantum number, that is the n is equal to 3. If the value is n is equal to 3, okay, what you can say, and 3, the 3 minus 1. What is the value? That is 2. It means if the principal quantum number is 3, the L value should be 2. Okay, see here, the maximum value of the angular momentum quantum number is 2. Okay, now apply to the fourth, that is nothing but n value is equal to 4. So in that case, the 4 minus 1. Why? Because n minus 1 rule. Okay, 4 minus 1, that is nothing but 3. Okay, now see the value here, the 3 is there. Okay, so by this way you can apply this n minus 1 to the angular momentum quantum number to find out based upon the principal quantum number. Okay, each of the L is related to the shape of the particular subshell and space around the nucleus. And remember, the subshells as the shapes, particular shape, and each angular momentum has the particular subshell generally designated with S, P, D, and F that we have discussed in the previous lecture also. Okay, and third is the magnetic quantum number represented with the small l, small m, subscript L. It has integer values that is between the minus L and also the plus L, including the 0 also. It means it contains negative values and negative 1 and so on, and 0, and it contains the positive 1, positive values or positive integers also. Okay, here you can see the minus 1, 0, and also the plus 1. So these are the values. It may contain 0 also, or it may contain minus 2, minus 1, 0, plus 1, plus 2, and so on. If there is no symbol before the number, that is considered as a plus. Okay, if there is no symbol, the plus or minus symbol, that is nothing but the plus. It is the plus only. Okay, so here also there is another formula, that is 2L plus 1. It is followed, and the example, if the L value is equal to 0, let us consider if the L value is equal to 0, that is nothing but angular momentum quantum number. If the L value is equal to 0, then the values are only 1. What is the value? That value may be 0. Okay, first thing is 0. The first value comes is the 0. After 0 only, it may be positive or negative. So what they say, 0, if the L value is equal to 0, it contains only one value. That value is nothing but 0. ML value is 0, or magnetic quantum number value is 0. So let us consider if the L, that is nothing but angular momentum quantum number, is 1, then the values are 3. So what are those three? What are those values? That is nothing but minus 1, 0, and plus 1. Here you can see if the L magnetic quantum angular momentum quantum number is 1, you can see how many values? 3 values. Those 3 values are first 0, minus 1, and plus 1. Okay, by this way you can see. So here the degenerate orbitals has a different orientation. That orientation is x, y, and z. For example, if you take the P subshell, the P subshell contains x, y, and z. So these are the 3 degenerate orbitals which have the same energy. All these degenerate orbitals have the same energy. Okay, and if you take the fourth, okay, the fourth shell, if you take the angular momentum quantum number is equal to 3, how many values we can see? So 1, 2, 3, 4, 5, 6, and 7. You can see the 7 values. And if you see the 2, if the value is 2, how many values you can see? 1, 2, 3, 4, 5. It means if the L is equal to 2, you can see the 5. And if you L is equal to 3, you can see the 7. 1, 2, 3, 4, 5, 6, 7. Okay. So these are the magnetic quantum number values that can be completely based upon the angular momentum quantum number. So by applying the value to L plus 1, you will get the value of the magnetic quantum number. Okay. So now let us move to the another quantum number, that is spin quantum number. So this spin quantum number describes the property of the electrons. So what are the properties? That is nothing but in which direction the electron is spinning. So it refers to the two possible orientations, or two possible orientations of the spin of an electron. Those orientations are represented with plus half, minus half. So the plus half is nothing but the clockwise, and minus half means anti-clockwise. So if the electron is spinning in the clockwise direction, that is nothing but plus half. If the electron is spinning in the anti-clockwise direction, that is nothing but minus half. So this is about the spin quantum number. The spin will be parallel when the both values are positive, otherwise anti-parallel. So what is meant by parallel? Parallel means in this way. Okay, this is the parallel, and here we have used the anti-parallel and parallel. Anti-parallel means in this way. One is in the direction from bottom to top, another is in the direction of top to bottom. This is known as anti-parallel, against to each other. These directions are against, but they are adjacent to each other. So this is known as anti-parallel. Then what about the parallel? Okay, in this way. Okay, they are the same parallel means they are heading towards only one direction. Okay, this is known as parallel. So this is anti-parallel. Okay, and I hope this lecture is helpful to you, and also you can subscribe to our channel, and if you like the video, click on the like button, and also you can share and comment. Provide your valuable suggestions in the form of comments, so that we can improve a lot in providing better education content. Okay, and if you dislike the video, click on the dislike, so that and also let us know the reason for dislike, so that we will improve a lot in providing the valuable education content. Okay, so and we will discuss the next topic in the next lesson.